Hello class, this is a video tutorial on solving and graphing inequalities. Inequations, or inequalities, are solved almost identically to regular equations, except the solution is a range of values. So for example, if we take this equation, we get a single value, x equals 3, whereas if we solve this inequality, we get x is less than 3. This means all the solutions less than 3 are a valid answer. So I could put x equals 2, x equals 1, x equals -1.5, etc. But rather than write all those values, we just write x is less than 3. Also need to take note, when multiplying or dividing by negative values, we change the direction of the inequality. So for example, we had here -2x is less than 4. If we divide by -2 on both sides, it becomes x is greater than -2. So that sign there has to change directions when dividing by negative values. And lastly, when graphing the final solutions, we follow the rules shown. It doesn't matter what number it is, so long as you understand that if it's greater than or equal to, we make a solid circle pointing to the right above the number. If it's x less than or equal to, it's a solid circle above the number pointing to the left. And if it's greater than but not equal to, it's a hollow number pointing to the right. And similarly, if it's less than but not equal to, it's a hollow circle pointing to the left. Alright, let's get this started. Solve the following inequalities and graph the solutions. You can pause this at any time and give it a go yourself. So when solving these, we treat them as we would regular equations. So we're going to subtract 7 on both sides. 10, dividing by 5, 2. Very straightforward there. Now we just draw our x-axis here. X, 2, draw a solid circle pointing to the right. There it is. Very straightforward. Let's solve this one here. I'm gonna do this in 2 ways just to show you that it can be a lot easier. Let's do it how most would immediately think to do it. We subtract 5t on both sides. So this becomes -2t minus 2 is less than -4. Adding 2 to both sides, we get -2t is less than adding -2. Dividing by -2 becomes +1, but we need to switch the sign like so. Let me just graph that one now. Oops. There's my x-axis. There's 1. A hollow circle pointing to the right. Now I'm going to repeat this one just to show you how if we do it a different way, we don't need to worry too much about flipping the sign. I'll show you what we mean. So when I initially solved it, we subtracted 5t on both sides. In this case, I'm going to subtract by 3t to make sure that t remains positive. So subtracting 3t on both sides, we get -t is less than 2t minus 4. Adding 4 to both sides, we get 2 is less than 2t. Dividing by 2, we get 1 is less than t. Or if we just switch everything around, as in just rotate everything, this is you can read this actually as t greater than 1. So this can be written as t greater than 1. Notice how if you just take note of whether or not the pronumeral is going to be negative, you can avoid having to turn the sign around. Okay, let's just move on. For this last example, it's a double inequality, but you shouldn't fret too much, because all it means is we're going to apply this -7 or whatever operation you're doing. If you do it once to this expression, you do it to each inequality, like so. So it becomes 2x in the center less than or equal to 11 take away 7 is 4, greater than 1 take away 7 is -6, and then we have dividing by 2 becomes 2, greater than -3. Now when we graph this, we have to graph both of them onto the same graph here. So let's write my 2's positive up here. Oops. 2, and -3, let's say it's about over here. -3. So they're saying that x is in between here. So x is less than 2, solid, because it's a less than or equal to, but it is greater than 3. So it's pointing this way to the right, but this way to the left. So if you notice that they both meet, and it's just this region that x is in, right? Not including -3, but including +2. Okay, so I hope that gave you an insight into solving inequalities and graphing them. Best of luck.